Hey guys. All right, so I'm back to go over the exam 2 part 2 review B. This is the second portion of the part 2 review. So we're going to start this section right here with some probability. I know this is going to be chapter 5 stuff because look, I have all these two-way tables, okay? So I'm going to just dig right in and get right to the answers and what we're looking at here. So this first one says, when selecting an RIT student at random, what is the probability that the student is female? So I want you to shade and outline and do whatever you need to do to work through this problem. So here, I want to always make sure I write some notation down if I can. And remember what I told you guys in class? I know this was a while ago. I'm not really that picky. So I'm just going to say probability of female. I think even on the solutions, on the other one, I just put F there. It really doesn't matter. I'm not going to use probability rules or, formulas. I'm going to use the two-way tables. I like them. They're so quick and simple. So the probability of just choosing a female, that's what I'm interested in. So that's what I'm actually going to highlight, all of this. There's my shading. When I do my shading, I just add up each box once, and that's my numerator. So this adds up to 5,147 divided by all of the students, which right up here you can see the table total. I know it's a little blurry, but that's 15,318. Okay, right there. You don't have to simplify anymore. I am perfectly fine. I actually prefer you to leave your answer in this form rather than simplifying or putting it into a decimal or a percentage. Okay, so let's look on to part B here. So what is the probability the student is from the College of Business or is female? Remember, or if we're thinking about formulas, it's the addition. So I'm going to have a lot more than if it was an and, which is where it's the overlap. So for B here, I'm looking at female. So I'm going to shade all of this in here. Get this all kind of shaded. And then it said, or business. So College of Business here. Okay, so I'm going to include those males that are part of the business. So when I'm doing the shading, I just add up everything that is shaded once. So I'm going to write my notation. So probability, I'm going to abbreviate even more because I don't have tons of room. Female, and then I'm just going to write an or because I'm fine with that. College of Business. And this is 5,893 that I've highlighted out of the total, 15,318. Now let's take a look at part C here. So when choosing among females, this is my conditional. As soon as I read that, I'm only choosing out of the females. So that's my conditional probability. I'm just going to outline females because I'm putting that condition. So I'm only looking at the females, but now what am I interested in calculating the probability on? What is the probability of selecting a student from the College of Engineering? Okay. So College of Engineering right here, COE. So that's what I'm interested in. So I'm going to highlight that or shade that in. And I'm going to write my notation. Now this is sometimes where we get a little tricked up on the notation. So remember, it's what I'm interested in first and then given my restriction. So it's the probability that someone's from the College of Engineering given that they're female. And there's my notation. So my shaded is 456. That's my numerator out of just that column, out of just that outline. That's why you outline. So we can see up here at the top, because the total is given to us, which is so nice, 5,147 is my denominator. All right, let's look at the last one here, part D. So if you randomly choose a student from the College of Imaging Arts and Sciences, what is the probability the student is female? So again, this is going to be my restriction. So it just says, okay, I'm randomly choosing from the College of Arts. So it's saying, okay, given that they're the Imaging Arts and Science, what is the probability? So I'm going to write my notation first on this one, actually. So the probability is what I'm interested in. I'm interested in a female student given they're from the College of Imaging Arts and Science. So that's CIAS. So now I'm going to go to my outline. So I'm I'm outlining the CIAS students, and what I'm interested in is if they're female for this one. So again, the shading is my numerator, and the total here, which is so nice up here, 2,154, is my denominator. Awesome, I love this. So now I'm gonna go back to part E here, which I'm not calculating probabilities anymore, but it's kind of like a follow-up question. So are the events female? So that was part A. And College of Imaging Arts and Sciences statistically independent. Okay, so I want to know what I'm looking at are these two. Okay, are these two independent? So does this, putting this condition of College of Imaging Arts and Sciences on the female, does it change the probability? So if we don't know, we can actually just take our calculators and see if they're the same. If they're the same, then when you divide them out and you get your decimal, then it means that they are independent. So I get 0.336 for this one. Now I'm going to see what it is when I have my condition. And I have 0.55. So they're different. So they are not equal. So they are not independent. Okay. And that's all it is to that one. Remember, we also have something called mutually exclusive. That just means there's no overlap. So like two mutually exclusive events would be female and male, right? Can't be both. All right, you have no overlap. Or another mutually exclusive could be the different college you're in. So College of Business is exclusive from College of Engineering, right? There's no overlap. That's mutually exclusive, in case you see that. All right, let's take a look at question 2 on here real quick. So question 2, we're talking about health and, oh, would you give up desserts? Never. So that'd be my answer. So in exchange for 5 extra years of life, 58% of Americans said no. I would be in that 58% for sure. So this health fitness expert decides to ask 50 randomly selected Americans, if you would do this. So here, I want to describe the objects and the variable, okay? So, and I want to be able to know, is the variable numerical, categorical? That's what this is all about, okay? So who are we asking the question to? It's just Americans. It's nothing, fancy, just Americans. That's who we're asking, right? So the question's a yes, no, right? I hope you picked up on that. First of all, you were given a percentage and, it said, these people said no. That's what I'm interested in. So it's going to be categorical because it's a yes, no question. So then what do we have about this? We actually have P. P is P is my population proportion. So that's 0.58 or 58%. Okay, so now let's move on to part B. So what proportion of Americans in Sandy's sample would you expect to say no? So what do I think the typical value or the center would be? Well, all I have is the 58% from the population, so I'm guessing it would be the same. So this is kind of looking to me like we're talking about a sampling distribution, and I bet we are. So here, this would be my center 0.58, because that's all I have. Right? So what is the standard error proportion of no responses in the sample? So this would be my standard error of p hats, and I have my square root of 0.58, 1 minus 0.58. Sorry, I was trying to squeeze this in here. And my sample size we said was 50. So here I get 0.0698. I'm going to leave that in 4 decimal places for now. Is normal appropriate? Remember what I have to do here? That's n times p times 1 minus p is greater than or equal to 10. And yes, I use p, not p hat, because that's what I have as p. So here I have 50 times 0.58 times 1 minus 0.58 is greater than or equal to 10. And yes, it is. It's 12.18. So yes, normal. Okay. All right, moving right along. Part C, 30% of the samples like Sandy's will have the proportion of no responses less than. Okay, so here I'm telling you the percentage. So this is one, I feel like the wording is a little tricky. I'm not crazy about the wording, to be honest. But I'm gonna just draw a picture with what I know. So it says 30% of the samples are less than. So I'm guessing that down here, I'm looking at this area and it's 30% here. So I want this data value, which I'm out of space, so I gotta put it up here. I didn't leave myself enough room at the bottom. And my middle here is 0.58. So if I have the area, I want the value, I'm going to use my inverse norm. So inverse norm, area to the left is 0.3 or 0.30. My center is 0.58 and my spread is 0.0698. Remember, when you're doing sampling distributions, don't forget to use the correct spread. So here I get 0.5434. So it's actually a lot closer to the center than I led it to believe in the drawing, which is fine, doesn't matter. So it's just saying 54.34%. Okay. So here it's just my data value is 0.54 or 54%. Because remember, this was the weird one when you're sampling distributions of P. It's a percent of a percent, okay? So 30% of the sample proportions will be less than 0.54 or 54%. All right. So now what is the probability? I know I'm looking for P. Probability that Sandy's proportion will be between. So 0.6 is less than or equal to, do a P hat here, less than or equal to 0.7. So you could draw another picture. You can use the same picture, whatever you want to do. I'm going to just draw another one. It's like super chintzy sketch, but we get the idea. So 0.6 is up here and 0.7. It's probably not even really to scale, but 0.6, 0.7. But that's what I'm looking for, and I want the area. So this is normal CDF. Lower bound 0.6, upper bound 0.7, center was at 0.58, and spread is 0.0698. So here I get 34.4% as my area here. This is 34.4%. So 34.4% of the sample proportions are between 60% and 70%, or 0.6 and 0.7. Awesome. Okay, let's move on. So I have like very little room here. So let's take a look. Okay, so the cola packages, soft drinks, glass bottles. Okay, they're thinking about a new supplier. So okay, so I'm reading through this. I'm not really sure where I'm going with a mean 157. I can just write it down if I want. Right there, it's numerical data. I don't have to really read what it's about or even get it yet. Standard deviation is 3. So they want to examine a random sample of 48. So N is 48 here. So I want to describe the population. So the population here are the new bottles from the company, and it's numerical. And the variable is the pressure, right? The PSI, okay? And that is the PSI in the bottles. That's what I'm studying from bottle to bottle. That's what's changing from one bottle to another. That's my variable. That's what's numerical, okay? So what do we know? We know this information: mu, sigma, and n. Okay? So let's fill this in. A typical value of the mean sample is my mean, 157. Whoops, 157. I was going to take off the 1. The standard error for the sample is, now I have to do a calculation over here because I'm out of room. Didn't leave myself enough room. So my standard error is going to be sigma divided by square root of n. So 3 divided by the square root of 48. And I actually find this to be 0.433. I'm just going to put that in here. Is normal appropriate? So remember, for numerical, I'm just going to quickly look to see if n is greater or equal to 30, because if I can use it, I will. It's the easy way out. I don't have any raw data. I skimmed, so I don't even know if I was told. I might have to go back and read slowly to see. but n is 48, so 48 is greater than or equal to 30, so yes, normal. Awesome. All right, so this one continues. So if a sample has an average greater than 157.5, will they start buying bottles? So what is the probability of this happening? So I want to draw out my picture real quick. That's not the greatest picture, but we have it. So what do I have here? My center is 157 from the previous page. Actually, I'll leave that up right here. So from here, I have 157, and it wants to know if it's 157.5. That's really close, especially since my spread is 0.43. So it's probably not that close. That's all right, I'm gonna leave it where it is. 157.5. So it's a little over 1 standard deviation away. It's probably closer to here. All right, or standard error, I should say. So let's go ahead and find the probability of this. I want to find that. So it's normal CDF. My lower bound, 157.5, upper bound, 10,000 for me, because that's what my calculator is at. 157, and my spread was the 0.433. So I plug that in and I get 12.41%. So this area is 12.41%. That's why I told you my graph was off a little bit. That's okay. It's only for me. So it's saying that 12.41% of the bottles have more than this PSI, 157. All right. So the next one, there's a 5% chance that the sample average pressure will be more than. Just when I see this, 5% that it's more than. So I'm looking over here and that this is 5% right here. Remember the center is still 157. So I want to know this data value. That's what I'm solving for. Inverse norm. Area to the left. Don't get confused. I know this top part is 5%, but I need area to the left. So 0.95 here. 157 and 0.433. So here I get 157.7122 for my PSI. Okay, would be the top 5%. All right. So questions form 5, it says, determine if this is a CI for means or proportions, and then write the correct formulas. You're not actually solving anything for these. We're just going to identify what's going on. So when I look at this, I just read the first like 4 words. How long do people? So when it says how long, that's time. To me, that's a meaningful number. So I'm going to keep reading what it's about. So I'm just going to highlight though how long. That makes me think it's a number. People avoid going to the dentist. A local dentist wants to estimate the mean. Right there, mean, numerical. Okay, so this is numerical data. So it's a CI for my population mean mu. Okay, now I'm going to write my formula. I didn't even finish reading the statement. I'm going to write my formula. It says with 90% confidence. I want to estimate. So numerical, it's x bar plus or minus. Remember for numerical, it's t at alpha divided by 2 times my standard error, s divided by square root of n. Remember we use s here because we don't have sigma. That's all I had to do for that one. All right, so let's go to the next one. What proportion? Right there, proportion. I just had to read the first 2 words and I could see proportion. So this is categorical. And so this is a CI for he. I don't have to read anything else. I'm gonna. Americans think the lottery will make them rich. A financial advisor would like to estimate with 95% confidence the proportion of all Americans who believe that the lottery is going to make them rich. Okay, so my formula is p hat plus or minus. Remember, this one is a z curve at alpha divided by 2 times my standard error. So my standard error here, I have to remember, do I use p hat or p? You actually use p hat. It's the same as the center. 1 minus p hat over n. There it is. There's my formulas. Okay, so now number 6, it says to estimate the average. Estimate's my keyword here. Estimate means I'm going to calculate a CI, okay? So I know I'm going to look at a CI, average dominant risk size. That means a meaningful number to me, okay, of adults. So here, 51 students were asked. So N, I'm gonna just write it to the side, N is 51. We're asked to measure the dominant risk. The sample mean, X bar is 17.71. Sample standard deviation, S, is 1.27. All of that, when you see means, and you see like the sample mean, and you see sample standard deviation, you only get that for numerical. So I know this is numerical. I'm just gonna write that here. So we know that's for numerical data. All right, so estimate. I'm using the same formula I just wrote up here in number 4. So I have 17.71 plus or minus. Now I need to get my t value. I'm gonna use my table on this one, and hopefully I can. Yep, 51. And does it say 95% confidence? So I'm gonna go to 95, that's my third column, 51. So I need to look for n minus 1. Oh, of course, it's not on the table, this one. So this one, 51, let's go to our calculators then. Go back up. Inverse t, area to the left. Okay, I need to look. It's 95, so that means 5% in the two tails together, so 2.5%, 0.025. Degrees of freedom is 50 because it's 51 minus 1. So -2. Okay, so here I'm going to just use 2, and I'm actually going to use 0.00856. I'm just going to go out a little bit further. You don't have to go that far. I just like to be certain of it. S is 1.27 and square root of 51. Squeeze that all in there. So once I find this, I get my answer here, 17.71 plus or minus. I'm going to write my margin of error. I don't think I calculated it. So 2.00856 times my standard error, which is 5.6232. I get 11.2945. 11.2945. That's my margin of error, and 17.71 is my point estimate. So then I'm going to add it, and I get 29.007. And for my upper bound, I'm going to subtract it from my point estimate, and I get 6.413 as my lower bound. Right here is my CI. Now, if I want to interpret that, I would say we are 95% confident that the average, that the population mean dominant risk size of an adult is between the 6.4 and the 29.0. Okay, what's the point estimate of your CI? Point estimate equals X bar, just abbreviating here, 17.71. Okay, what is the margin of error? So margin of error, or sometimes you'll see it just error like this, is equal to the 11.2945. Okay, awesome. We go over number 7. All right, you do not know the proportion right there. I don't have to go any further. I see proportion. That means categorical right away. No, I'm studying proportions. Look at this. Random sample. I don't like skimming. I tell you guys not to skim. Please don't skim. So the proportion of population Americans who watch TV during dinner. To explore the population, you obtain a random sample of 50. So N is 50. Within your sample, you find that 20 do. So that's X. X is 20. So that means P hat is 20 divided by 50, right? So here, I have my n, my x, my p hat. So you can see on the next one, it says to estimate, right? So here, I'm just gonna go ahead and put that there. So here it says, what is the point estimate? And look at what I do here. You've been asked to give a statement about the proportion of Americans who watch the TV. You state that you have a high confidence that the proportion is between 0.40 plus or minus 0.135. It's already been given to me. So my point estimate is 0.40. It's my p hat. Oh, awesome. I love it. So p hat is that. I'm going to say point estimate. Kind of abbreviate there. And then margin of error, or you could just say error, is going to be the 0.1358. So all this math has already been done for you. What's the lower and upper bounds? Well, the lower bound is when I take 0.4 minus the 0.1358. So here, lower bound is 0.2642. And my upper bound is when I add the two together. So I have 0.5358. Awesome. Approximately what percentage of the curve is between these bounds? And I tell you a hint, this is your level of confidence. So we need to look to see what our level of confidence could be. So here we're kind of going to work our way backwards a little bit and see what our z could possibly be. So my error is 0.1358, right? This is equal to my z at alpha divided by 2 times my standard error of p hat. Well, I know what standard error is, right? So I can just go ahead and plug that in. I can find that standard error is that square root of p hat 1 minus p hat n. So I can find that standard error actually is, I'm just dissecting this, 0.06928. I feel like I'm running out of room. Okay, so now if I have that and I have the error, I'm just going to solve for z. So I'm going to take, so this is my formula I have, 0.1358 equals z value times 0.06928. I'm going to divide both sides by the 0.06928. And I'll cancel on the right side, and then I find my z. Z is equal to 1.96. Well, I can use my, my normal CDF if I need to get that for my z. Remember what z is, 0 and 1, or I can just remember, well, 1.96 was the z-score if I had 95% confidence. So remember, you could always do this by just plugging in your values into your normal CDF. You would find 95%. Okay. Can you be 100% confident your interval contains, the unknown proportion for the population? No. No, we are only 95%. So no, not 100%. The proportion of all Americans who watch TV is greater than 26. Based on the interval, can that be true? It's 26%. So I'm going to go back up to my lower bound and my upper bound. The lower bound is 0.26, so it is above 0.26, and this is a greater than statement. So yes, the CI is greater than 0.26. That's it. That's all I had to do. This one was the trickiest one. C. It's something we haven't really done or talked about or looked at before on like a team assignment or in class. All right, I hope this was so helpful for all of you. I will talk to you soon.